Absolute value and exponents. Absolute value is the distance a number is away from zero on a number line, where the distance is always positive. Absolute value is represented by two vertical bars surrounding a number. Find the absolute value of the following numbers. So number 1, the absolute value of 5, is really asking how far away from 0 is 5 on a number line. Well, 5 is 5 spaces away, so the absolute value is 5. Number 2, what is the absolute value of negative 2? Well, negative 2 is 2 spaces to the left on a number line, but it's still 2 spaces, so it's a positive 2. Distance is always positive, so absolute value is always positive. Number 3, the absolute value of negative 6 is just 6. 4 is interesting. We have a negative sign, but it's on the outside of those absolute value bars. So the negative sign just comes down for our answer, and the absolute value of 4 is 4. So the negative absolute value of 4 is negative 4. Number 5, the absolute value of 13 is 13. Number 6, this time that negative sign is inside the absolute value bars, whereas in number 4, it was outside, okay? But it's inside, so the absolute value of negative 13 is 13. On 7, we have one on the outside, so I'm going to bring it down. And then the absolute value of negative 100 is 100, so our final answer is negative 100. Number 8, the absolute value of 0 is 0. What do you notice about 5 and 6 above? Well, if you look at number 5 and 6, they have the same absolute value because they're both 13. Pause if you need to in order to write that down. So the numbers 13 and negative 13 are considered opposites because they're the same distance from 0 on either side. Determine if each set of integers is greater than, less than, or equal to one another. Okay, so the absolute value of 0 is 0. The absolute value of 12 is 12. 0 is less than 12. Number 10, the absolute value of negative 5 is 5. The absolute value of 5 is 5. 5 is equal to 5. Try number 11. The absolute value of 43 is 43. The absolute value of negative 42 is 42. Therefore, 43 is greater than 42. Number 12, we have 1 and 9. 1 is less than 9. Number 13, we have that negative on the outside, so make sure you bring that down. So this becomes negative 6. And this one is 4. 4 is greater than negative 6. Number 14, it looks like both of my negative signs are inside the absolute value bars, so this is nothing special. Negative 23, the absolute value is 23. And the absolute value of negative 32 is 32. 23 is less than 32. Number 15, the absolute value of negative 2 is 2. And here we have a negative on the outside again. Bring it down. The absolute value of negative 3 is 3. 2 is greater than negative 3. Try 16 and 17 on your own. Okay, for 16, we are comparing 8 and 14. 8 is less than 14. And in number 17, we're comparing 99 and 100. 99 is less than 100. Okay, the next thing we're going to talk about are exponents. In a power, the number that tells us how many times the base is used as a factor is called an exponent. For example, in 3 to the 5th, 3 is the base and 5 is the exponent. This means that 3 is being multiplied by itself 5 times. In other words, 3 to the 5th is 3 times 3 times 3 times 3 times 3. Simplify the following exponents. Okay, 3 squared is 3, times 3, which equals 9. Number 19, I have negative 2 raised to the 4th power. That means I'm writing negative 2 4 times. Negative 2 times negative 2 is positive 4. I can do that over here as well. And then 4 times 4 is 16. Number 20, I have negative 1 6 times. Negative 1 times negative 1, these are all positive ones. 1 times 1 is 1. Bring down that 1. We get an answer of 1. Notice how when I have my negatives, I'm keeping the negatives in the parentheses. Okay? That's very important. You should not write this one negative 2, negative 2. It gets too confusing. Okay? Please make sure the negative stays in the parentheses. With that in mind, we can actually do these in our calculator. Okay? So in our calculator, we've got parenthesis buttons, which are above the 8 and the 9. And then we are going to use a little caret button, which is diagonal from the 7. So the caret button looks like this. So when we type it in our calculator, we hit parenthesis, negative. The negative sign is the white button under the 3. So negative 3, other parenthesis, caret 3. And when we type that in our calculator, we get negative 27. The parentheses are so important. When you see parentheses, you type parentheses. Number 22, I don't see parentheses, so we're just typing in 4, caret 3. Go ahead and type that in. You should get 64. Number 23, again, you're going to type in those parentheses. Negative 1, or parenthesis, negative 1, parenthesis, caret 5, and you wind up with negative 1. Okay, so if you take a look at these examples, more specifically, when I'm asking what do you notice, more specifically, I'm talking about when we raise a negative number to a power. So I'm talking about these examples. When the exponent is odd, an odd number, the result is negative. When the exponent is an even number, the result is positive. So, even exponent, positive answer. Similarly, odd exponent means a negative answer. So let's take a look at a couple similar looking ones. Negative 5 squared. So let's type it in our calculator. Negative, or keep saying that, parenthesis, negative 5, parenthesis, caret 2. We get a positive 25. And over here, we're just typing in 5, caret 2. And we also get a 25. So let's compare them. Well, they're the same. So let's look at another example. So this time, they're both negative, but one negative's on the inside of the parentheses, and one negative is not on the inside. There are no parentheses. So we're going to type it in exactly how we see it. Parenthesis, negative 4, parenthesis, caret 2. We get 16. And this one, we're typing in negative 4, caret 2. And this time we get negative 16. This is why parentheses are so important. If you see parentheses, you type parentheses. So comparing these, they're different. And we're just going to point out that the negatives are either in parentheses or not. And I want to put this note here, parentheses matter.